Okay, so let's take a look at that. Okay. Okay, so remember with compound inequalities, you are looking at either two parts of your inequalities being connected by the word and, or two inequalities being connected by the word or. So the idea is depending on which connecting word is being used, you're going to get two different types of answers based on that. So if you guys have done maybe in one of your earlier classes set theory, then you may have heard about intersection or union of sets. But the idea behind intersection is if you have two separate sets and we're only looking at the intersection for those sets, that actually means that you are only looking at numbers or values which will be common between the two sets. So if there's anything that one set has but the other one does not, you don't put that in the intersection. So the intersection has to be exclusively numbers or values that are in both of your sets. So this is the little inverted U symbol that we use for intersection. And for just in terms of terminology, when I'm saying X is an A, we're basically saying X is an element or part of set A, and we're also saying X is also a part of or it belongs to set B. So as I said, they have to be in both sets to fall under the intersection. Union, on the other hand, is literally taking everything from set A to set B. If it's common to both sets, you put it in there. But if it's in one set and not the other one, you still put it all together. So you're basically bringing all the elements from both sets and you put it all together to create a union of your sets. And then this one kind of looks like a U, but it's not. This is what we use as the union symbol. So in this case, you can have either or, which means your sets don't have to have an overlap. Even if they are two completely separate sets, they will work together. You guys may be familiar with the use of Venn diagrams. So usually when we're talking about intersection, so we're saying A intersected with B. So the idea is if we have two sets, A and B, then the intersection is only going to be this part, which is common to both of them. So the idea then here would be the values that are in A but not in B get left behind. So this would be sets that are in both A and B. When you're talking about union, on the other hand, if you have two sets, let's say they still have something in common, you would actually end up taking stuff that is common, but you also end up taking everything else that is not common. So that's the difference between intersection and union. Intersection is only the common values go in the intersection. Union is common is fine, but everything else also. But you can actually also have sets that have absolutely nothing in common. So they are two completely different sets, but when you're talking about union, you're basically saying take everything from set A, take everything from set B, and you still put it together. Say that one more time. Belongs to is for this little symbol here. So this is saying that X is a number which is part of set A. So that would they basically mean if I have X in set A, but I should also have set X in set B for it to fall in this intersection part. If I have X here, and let me change my color. If I have X here and Y here, then, you know, in intersection, that would be blank, right? Because they are not part of the same set. But when you're talking about union for X and Y, even though they are not in the other sets, you still bring them together. But in an intersection, if they are X and Y, there's nothing common, your intersection would basically then be blank because it has to be in both sets for you to include it in the intersection. Okay, so how are we going to use that is going to be a little bit different because, you know, we're looking at these as intervals. Remember, we talked about the interval notation last time. So we're looking at these as intervals. So we are basically going to see what portion of the intervals is going to be common between both our inequalities, and that's what we're going to include as part of our solution set. So the first one you can see is the AND example. So they're asking us to solve the compound inequality and then of course write our solution set both using a graph and using our interval notation. So let's go ahead and take a look at this first example here. So we've got 5 is greater than 8 minus x, and 1 plus 0.5x is less than 4. So of course, each inequality we're going to solve separately, right? Like we looked at example 2 last time, which means on the left-hand side, we want to try and get that 8 by itself. So what can we do? I'm sorry, the x by itself, move the 8. See that? And what operation do we use to get rid of the 8? Very nice. So start by subtracting the 8. 5 minus 8. Very nice. Negative 3 is greater, and that x still has a negative sign on it. So now what do we do? Because we still need to get x by itself, right? We don't want that negative sign. Yeah, very good. Divide by negative 1. And in an inequality, if you are dividing by negative, you have to change the direction of your inequality. Very good. So that will actually now be a less than instead of greater than. Your x has now become positive, and what's 3? Negative or positive? Yeah, positive. 2 negatives become positive. So I'm just going to rewrite this. So I've got x, and then the greater than is facing the x, so that's going to be x greater than 3. Okay, so again, just to remind you, if you multiply or divide your inequality by a negative number, change the direction of your inequality. For everything else, keep it the same. Alrighty, so now same process on the right hand side. We again want to try and isolate our x. To start by moving that 1. What do we do with the 1? Yeah, subtract 1. Very nice. So subtracting both sides by 1, we end up with 0.5x less than 3. And then what do we do to get x by itself? Yep, very nice. Divide by 0.5. And 3 divided by 0.5 is going to be 6. Okay.
So this one, the sign doesn't change, right? Yeah.
Right, because you're dividing by a positive number, so the direction does not change. Very nice. And multiply by negative, yeah. Okay, so I actually want to show you how this and between the two inequalities is going to work. So if I show you graphically, this is what we have. The left-hand side of our inequality is saying x is greater than 3. And that's just greater than, right? There's no equal to, which means you use parentheses. And we're greater than 3. For the other one, we are saying x is less than 6. So less than, again, there's no equal to in there. So this is a parentheses. And then less than 6. Okay. Now the idea is this is a compound inequality, which means we actually have to combine this into one single solution. So if you look at these numbers, we've got 3, we've got 6. From one side, we are saying x is greater than 3, which means it will keep going here towards positive infinity. The other inequality is telling us x is less than 6, which is going in this direction towards negative infinity. And in a compound inequality represents intersection. Okay, So when they give you an and inequality, they are basically saying only the parts that are common between the two answers we got is what you're going to be including as part of your solution set. So if we go back to that common single graph here, you can see this is where my answers are overlapping, right? Because here, this is only the red part. Here, this is only the green part. So that means those were not the common area. So it's between 3 and 6 where both my solution sets are overlapping each other, right? That's my common intersection area. So when you actually write your solution set, graphically, it's going to be between 3 and 6 only, and none of those numbers were being included, so parentheses on both ends, and it's just going to be that middle part between 3 and 6. You're not going to be shading on the left or the right of those numbers because that's just the common area, right? And then as an interval notation, so that was your graph, your interval notation is only between 3 and 6, right? So that's it. You're not going all the way to infinity in this case. Because remember when we talked about compound inequalities, if you go back to the top of your handout, you're actually looking at this open interval, and this is what your graph is going to end up looking like. So this is the example that we just did. So solve each inequality separately, get your x values by themselves, right? Keep a positive x when you solve these. And then the idea is with the and, we are looking at an intersection, which means you are only interested in the part where you're going to see the overlap between your two individual inequalities, and that's going to end up giving you your intersection, and your interval notation will end up looking like this. That's just for explanation. I mean, the final answer would, of course, be just this guy here, and then your interval notation. Yeah. So if you want to do the individual ones, you can, but it's not necessary. That's just for I could show you how they end up overlapping. Okay. Now, the next example is with an or inequality. So if and was intersection, or is going to be union, right? Because that was the other thing we talked about. So let's see how the union will work in these sets. Okay, so this guy is number 4, and we've got 1 minus x less than 7 plus x, or 4x plus 3 greater. So again, solve each inequality individually. In this case, of course, you can see on the left-hand side, I have x on either side of our inequality. So let's get those x values on the same side. So which one do we want to move? You want to move the negative x? All right, so that means he will become, what will he become when you move it? Yeah, so add that x to both sides. This cancels out. On the right side, we have the 1 left behind, less than 7 plus 2x. Then, of course, go ahead and move your 7, right? So we'll subtract that 7 on both sides. Negative 6 less than 2x. Divide by 2. Very good. Negative 3 is less than x, or x is greater than negative 3. My brain just prefers having my x on the left-hand side, so I usually always rearrange my inequality. If you guys are comfortable with negative 3 less than x, you don't have to rewrite it. I just prefer to rewrite mine. Okay, now solve the right-hand side. So that's 4x plus 3 greater than x. Again, you've got x on both sides. So what do we move? Yeah, take that single x, move it to the left-hand side. So 4 minus 1x will of course give you 3x plus 3. And what do I have on the other side of my inequality? Yeah, 0, because everything canceled out. And of course, our goal is again to get x by itself. So start by moving that constant 3 to the other side. And this will be 3x greater than negative 3. Divide both sides by 3. Very good. Yeah. So again, let's take a look at what these individual graphs look like. So I've got x greater than negative 3. Again, we're not including negative 3. It's only greater than, right? So just do parentheses. The other one says x is greater than negative 1. Okay, so if I put these together, what will we end up with? Let's see, I've got negative 3 and negative 1. This guy is greater than negative 3. The other one is greater than negative 1. Okay, but this is an or inequality, right? If it was an and inequality, then this is where the overlap happens, and that's all we would be interested in. But this guy being an or inequality means we are looking at union of our sets. Union means take stuff that's common, but also bring stuff that is not common. So obviously these guys are going to be part of our solution set, but this is the uncommon portion, right? It's part of one set, but not part of the other one, which means we have to include this also. This was the only portion where none of our graphs covered that area, right? So
do we need to like have it color coded?
oh no, this was just so I could again show you that there's
So I
a
can just shade or.
yeah, definitely. I mean, if it's easier for you with colors, do it with colors, but yeah,
No, I
I'm
just
not,
wanted to make sure we didn't-
no, I'm not looking for like color coded or anything. As long as you understand the concept, I'm okay with that. Yeah? Okay, so how do you write your solution set for this guy? Uh-huh. Very nice, yeah, because remember what I said, include the common part, but also include the part that was not common. So that means you're actually starting from negative infinity and going all the way to positive infinity, and that covers everything, right? From negative 1 also. As your interval notation, as Ira mentioned, since we are going from negative 3 all the way to the right, it's going to be negative 3 to infinity. We're not including negative 3 because you didn't have that little equal to, right? It was just greater than. So parentheses here, and then remember what I told you, we never put brackets on infinity no matter what. So it's always going to be parentheses for positive or negative infinity. And then this symbol dictates if you're going to have a bracket or parentheses, which in this case is parentheses. So that's going to be your answer. Okay, questions on 3 and 4? Yeah. Okay, so if it's just greater than, it's going to be parentheses. But if you had greater than equal to, you know, with that little equal to sign, then instead of parentheses, we would do the square brackets. Okay.
Yesterday,
Uh-huh.
I use this all the time at work.
What?
When I'm leak checking parts
Uh-huh.
for like vacuum,
Okay.
we have to leak check it down to 1 times 10 to the negative 9 torr or less than.
Oh.
So it's less than 1 times 10 to the negative 9 torr.
Okay, look at that.
And I was like, Oh, this is all the
Look at that. I am very impressed. Very nice. Any guesses on what kind of example number 5 is? Is that an and or an or? It is actually going to be an and inequality, because you can see how your x is sandwiched between two different inequality symbols. So this is actually by default going to end up being an and inequality. So now the way you solve this guy, this is what we call a 3-part inequality. Not you. Okay, so you are number 5. Okay, so you've got -2 less than equal to 4 minus 6x, and then this is only less than 22. So the idea here is we want to leave the x in the middle, and we want to go ahead and clean up all the other numbers. But instead of doing it on one side, whatever add, subtract, multiply, divide you're going to do, we do it on all 3 parts of the inequality. So of course, the first thing we would want to get rid of is the 4 or the 6? The 4, yeah, the constant number. So since it's a +4, to get rid of it, we would need to do -4, but that -4 will go on all 3 sides of your inequality, which means in the middle, it will of course end up canceling out, and then we'll just add the numbers on the right and the left. So what do I get on the left-hand side? -6 less than equal to, you still have -6x left in the middle. Then just a less than 22 minus 4, 18. And of course, now the idea is to get that x by itself, which means we'll need to get rid of the -6. What do we do for that? Very good. Divide. Yes, very good. Your inequality symbol is going to change because we're dividing all 3 sides by -6. Levi? But if you divide by 6, then the negative would still stay behind with the x. You're talking about this 6, right? So if you didn't take the negative sign with you, then you would still have the negative left behind with the x, which means then you would again need to go back and make sure you get rid of it. So either multiply everything by -1 or again go back and divide by -1. So it just seems easier to take the sign with you when you're doing this division with the 6. So you're not breaking it up into 2 parts then. All right, so what do we get on the left-hand side of our inequality? +1. Okay, now remember the direction of your inequality has to change. So less than equal to will now become greater than equal to. We have only x left behind in the middle. The less than is now becoming greater than. And what's 18 divided by -6? -3. So since we divided by -6 here, both the directions of our inequality have to change. So please keep that in mind. And okay, I am actually going to rearrange this. So this is going to be -3 is less than x, which is less than equal to 1. So you can see one of my students had told me about, think of it as a, I think crocodile or alligator, whichever one you find more scary. So the open mouth faces the x. So that's what we did, right? The open mouth faces the x, which means I guess the tail end was towards the -3. And then the tail was towards the x, and then the open mouth is facing 1. So just make sure your directions always follow that. So this guy obviously does not have that 2 separate parts like we looked at with the and inequality. So if you look at the graph for this guy, our -3 will be on the left, +1 on the right. So this part here, you can look at it, this inequality or this one, doesn't matter. We are saying x is greater than -3. So what direction are we going? To the right, yeah, which means x is greater then -3, which means you're going to the right towards positive. X is less than or equal to 1. So what direction are you going? Left, yeah, less than, but then since they told you less than and equal to, very nice, use a bracket, and we are going left. And this is, of course, towards -infinity. So as I was mentioning, by default, these three-part inequalities are the and inequalities. And means intersection. So when we actually write the solution set, we're actually only interested in this part here where the two sides are overlapping. So we're going to ignore this left-hand side, ignore this right-hand side, and we're only going to stay in between those numbers. So our solution set, very good. So graphically, that would be from -3 to 1, not including -3, right? But including 1. And everything in between those two. Okay, Jacob, do you know what that interval notation will be?
So it'll be parentheses, -3, comma, 1 with a bracket.
Very nice. So you're literally taking the graph and translating it, right? So parentheses on -3, and then a closed bracket on +1.
Now we have one of them that half. That's one of them. That's half of them.
Yeah. Very good. Question on this guy.
So I guess, so on the tests and stuff, would we only do like the graph where you graph both of them, like they don't get their own separate graph? Because like in the earlier problems, you were doing a graph for each of them, for like the 3 and for the 6, and then you do them two.
Okay, I see what you're saying. You can actually do separate ones if you want, but since this was a 3-part inequality, I just showed you on the one. But yeah, I mean, you can. But the reason I do only a single one on this is just to show you that it is still going to be a single graph. You're just going to be going in two opposite directions, but that center part is where you're going to have the overlap. Yeah, very good. What else? All right, so again, remember in your homework and on the exam, the graph will be given to you as a multiple choice, so you're just picking which the right graph should be, but then you will actually be typing in your interval notation or writing it out, I guess, on the test since it's paper-based. Okay, so those were the examples of what we call as linear inequalities, okay? Now we're getting into our absolute value inequality. So again, absolute value is the distance from 0 on a number line. Since you can go in either direction to get that same distance, we still have to use that same idea when we're looking at absolute value inequalities. So when you have absolute value of x less than 5, we're basically saying whatever number that x is going to be, its distance is going to be less than 5, right? Because absolute value, again, is a distance. So we're saying it's going to be less than 5, which means on the right-hand side, the value has to be maybe somewhere from 0 to 5, right? Just not including 5. And on the left-hand side, it's got to be somewhere between -5 to 0. So that's why we're saying that it's going to be either between positive or -5. Think about it. If you have a distance of a number, which is going to be less than 5, that means it has to be somewhere within that range of value. So that's what that first inequality is talking about. When we look at greater than, so with the greater than, of course, we're saying the distance is more than 4, right? Which means you're actually looking at the other side. So if we do, again, as a number line, distance greater than 4, which means you have to be looking at this side on the other side of 4. If it's greater than -4, you're looking at the left-hand side. So you're actually going to be going away from your numbers. But when it's less than, you're actually looking in between those numbers. So it's actually, again, the idea of, are you looking at an and or an or. Compound inequality with absolute value and less than, it behaves like your and inequality. With absolute value greater than, it behaves like your or inequality because it's going to be going in separate directions. Okay? Yeah.
Since it's absolute value, that means there always will be a positive and a negative.
Yes, exactly. So just like we did with equations, that's the same thing that's going to happen. But the setup is going to be a little bit different. So this table kind of highlights that. Oh, what
What's the
happened?
U thing?
That's the union symbol. You saw that on a couple
Gotcha.
last page or a couple pages before that. So this is the union symbol, and we're not really using the intersection symbol here because that is kind of getting absorbed right here in this, but you will need to use that union symbol because they are going to be two separate pieces that we're trying to combine together. Okay, so remember with absolute value equations, we took the expression and set it equal to positive and negative number, whatever that number would be. Kind of following that same idea, but with inequalities, it's a little bit different. The first part is going to be exactly the same. You're just getting rid of the absolute value symbol and you're going to have x greater than k. But then for the other half, you are going to do x without the absolute value, change the direction of your inequality and put a negative sign on the k. So you have x less than negative k or x greater than k. So remember, when it's greater than, it's always going to be or. When it's less than, you can write it as a three-part inequality, or you can write it with and as your connecting word. So you can actually do like the way they did here with or. If you don't want to write it as a three-part inequality here for this guy, you can have x less than k and x greater than negative k if you wanted to use the and. Or you can just do the three-part inequality. So whichever one you think would be more comfortable for you. I actually like the three-part inequality because then it's easier to get your graph and then you know between what two numbers your x is going to be sandwiched between. Okay, so let's take a look at how we can actually solve these. And this is kind of what I'm talking about. You have two separate sections when you do the or inequality or greater than, and you have one single section when you do the less than or the and inequality. Okay, so number 6. We've got absolute value of 5 minus 4x less than equal to 1. So this is less than equal to, so think of this again either as the three-part or think of it as the and, however you want to set this up. If you do the three-part inequality, this is how you set it up. The 5 minus 4x will go in the middle. This will be less than equal to 1. So basically the same thing, right, without the absolute value signs. For the third part, you're actually going to use the same direction of less than equal to, but now this side will become negative 1. As I was saying, your other option would be 5 minus 4x less than equal to 1 and 5 minus 4x greater than equal to negative 1. And we still have that same thing, right? Greater than equal to facing the x term, the tail facing the negative 1. Greater than equal to facing the x term, the tail facing the negative 1. So you're still setting it up in that same way. Here you have two individual inequalities. Here you're doing it as a three-part inequality. You will still get the same answer no matter which way you go about doing this. So go ahead, solve this and tell me what x value are you coming up with. All right, we're going to find out, right?
If it was negative, I'm sorry, if it was negative 6 over negative 4, would that make it a positive 3 over 2 or negative?
Negative 6 over negative 4 would be positive.
Okay, yes.
Then you have both numbers positive?
Yeah.
Okay, well, he just changed his answer.
So we go to positive,
If both numbers are negative, if your 6 and 4 are
It's like
negative.
combining-
but they don't go into each other, or,
So you'll just reduce your fraction,
uh-huh.
yeah? But you're still getting negative? It should
Yeah,
become
it's-
positive.
Yeah.
But then the direction of your inequality has to change, right?
Yeah.
All right, so the first thing we're getting rid of is which number in the middle? The 5, yeah. So we'll start by subtracting 5. Let's bring this guy in. Subtract 5 on each side, cancels out in the middle. Yeah, you're getting negative 6 on the left, less than equal to negative 4x, less than equal to 1 minus 5? Negative 4, okay. All right, so we cleaned that part up. Now we want to get rid of negative 4. So we would start by dividing each side again by negative 4. And since we are dividing by a negative number, your direction of the inequality has to change, okay? So these guys will actually cancel out. For that matter, technically, these guys cancel out. Negative 4 divided by negative 4 ends up becoming 1, x in the middle. And yeah, so you've got negative 6 over negative 4. 2 negatives become positive, so these guys will become positive. And reduce 6 over 4, which will become 3/2. So we are actually getting x is less than equal to 3/2. X is greater than or equal to 1.
Would you want to write that as 1.5? Just for the sake of
As a
math.
mixed number, I don't think my math lab will accept a mixed number. I think they'll do fractions for this. I know they don't accept decimals. You can try it, but I'm pretty certain they only do fractions for this. Yeah, yeah. So most of the time they only want fractions, yeah. And you know, I mean, of course, 3/2 is 1.5, so you are literally going half a unit from it. So if x is greater than or equal to 1 and x is less than or equal to 3/2, what direction are we going in? Yeah, because when they are saying x is less than or equal to 3/2, you've got, of course, brackets because of that equal to. This guy is going less than. The other one is saying x is greater than or equal to 1, so you're going to the right. And being a 3-part inequality, I know we're only interested in the overlap. So that's going to be between 1 and 3/2. Both of them have brackets. And just that middle section. Okay, what did you do? Did you just leave it as positive 1? So this part here.
Correct, that negative 1 right at the beginning. And that's just because it's a 3-part, correct?
Yeah.
Can you go over why it's a 3-part?
Oh, why it's a 3-part? Because when you are looking at absolute value with less than, remember the idea is we're saying your distance can be between 0 and 1 or between 0 and negative 1 on the negative side, right? So that's why you're only going to stay right at that 1 and 1 on either side of 0. So that's why, since you're going to be sandwiched between these two values, we set it up as a 3-part inequality. If this original symbol was greater than or greater than equal to, that's when it breaks it up into 2 completely separate parts. So when it's less than equal to, you can set it up as a 3-part, or remember, you can also set it up as an and. And that is coming because of this symbol.
That's what I did. I did this over here.
Okay, and I'll show you those answers also. And it will come out to be the exact same result. Because otherwise it makes no sense to do it 2 separate ways. Can somebody tell me what our interval notation will be for this guy? Okay. Bracket again. Yeah, so you're going to have bracket on both numbers. And then this is between 1 and 3/2. All righty. Let me show you with the and inequality. So this is if you set it up as two individual inequalities. Same thing, you're trying to get x by itself. So we would start by subtracting 5. So he cancels out. You're left behind with negative 4x less than equal to 1 minus negative 5. Negative 4. Divide both sides by negative 4. And x is less than equal to 1. So this is that right-hand side, right, that we solved. Okay. Basically, these guys canceled out, giving you a 1 here. And then for your and part, the second half.
Can you flip the sign?
Yeah, we divided by negative. Thank you, Brian. It should be greater than equal to. Okay, thank you. All right, same exact process with the greater than equal to negative one, right? Again, start by subtracting that 5. And this guy will give us greater than equal to negative 1 minus 5. Negative 6. And then divide again by negative 4. And before I forget, change my direction. So negative 6 over negative 4, same thing as we got on this side, which will again end up cleaning up into positive 3/2. Now, Herbert, you were asking me this before. So since we set these up as the and inequality, you can actually get your two separate graphs from each one of these. So this one is saying x is greater than equal to 1. So this is going in this direction. The other one is saying x is less than or equal to 3/2, and you would be going in this direction. From here, we can obviously then combine these into a single. 1 3/2. Whoa. This guy is greater than, this guy is less than. That leads you to the same conclusion. So either way, so I would definitely not say do it as a 3-part or do it as an and inequality. You pick which method you think works the best for you. If you don't like the 3-part, don't even worry about it. Just do it as an and inequality. If you're more comfortable with the 3-part, I'm okay with you guys using the 3-part inequality also. Any other question on that? Yes.
When it starts to become, since it's absolute value, it's
Mhm.
gonna give a positive
Mm-hmm.
part, right?
Mhm.
So what determined that the 1 was the one that became negative and not the -5?
Oh, trust me, you don't want to try and put a negative there, because for most part, the problem I have is you don't remember to distribute that negative sign. And usually this guy gets left behind, and then that obviously will not lead to the right answer. So it's always easier just to take the constant term and put a negative and positive on that. I think it's just a simple thing about not forgetting to distribute that. And that's why it's easier to put the negative on the number instead of that expression.
So if we did remember, we could put it wherever. What is the rule that?
I will have to go through the math to see, will you still get the same answer if you put a negative here and not on the 1? So this will be just a simple process of calculating it and making sure, because there is a possibility, and I really have not worked this out, but if I put a negative here, I have a feeling my direction will not be the same. I think my direction will reverse, but I honestly have to work it out. I've never done it. Okay. But if you want to mess around with it and give me an answer, that would be great. So at least we can kind of see what happens if you move that negative to the other side. Now, here's the big difference. Both are absolute value inequalities. This guy was less than, which makes it the and or the 3-part inequality. This guy is the greater than, which makes this the or inequality. And there's only one way to solve number 7, unlike the example we just saw. So with number 7, let me write that down real quickly. We have absolute value of 3 minus 2x greater than equal to 5. Okay. So like I said, since this guy is greater than equal to, this is going to be an or inequality. Did it work?
No, it's opposite. It became like a negative.
That's what I was worried about, that your direction would change. But you know, I'm sure there's a workaround to it. And if you want to talk about it, we can kind of play around with it later. Just
Trying
to,
figure out
so you can kind of be in that. So this guy is an or inequality, and that's because of this greater than equal to. Okay, so when you set this up, the first one is going to be the same without the absolute value symbol. So 3 minus 2x greater than equal to 5. So that part will stay as it is. But then we're going to use or as our connecting word. Oh, wow. And now the other side will be, again, 3 minus 2x. Keep it the same. Change the direction of your inequality. Put a negative sign on the number. So greater than equal to will now become less than equal to. 5 will become negative 5. Same exact thing that you actually did in number 6, but you used and there. We're using or here.
Can you do
Can
it
you
that
do
way as
this
well?
3-part?
You cannot do 3-part on this. 3-part is only for the and inequality.
Oh,
Yeah, if you did 3-part here, trust me, it's going to look funky. Have you tried it?
I did.
Oh, and what did it give you? Probably like 2 opposite directions, right?
Well,
Yeah.
I don't know. I feel the solution because I couldn't figure it out. I
Yeah.
started breaking it down and I lost it.
Yeah, because you should technically have your arrows, or I'm calling them arrows, but your inequalities facing opposite directions from each other. So, Herbert?
So wait, why could we use the both of them on the first one?
Because of the less than equal to symbol on the original problem.
It has to be less than 2 part.
For a 3-part, yeah, it has to be less than.
Oh, I guess I was confused because the table it says the
Yeah.
that symbol you can do the 3-part. I didn't realize that it also means you can also do the x is less than or equal to
This guy, right?
down. Yeah, that one.
Yeah, so you can do the and for this guy also.
But you can also do the
And you can also do the 3-part. So yeah, you can do and for those 2 bottom ones. But these ones, or is the only option. Yeah.
Where do we flip it?
If you multiply or divide by a negative number, do we do that here? Yeah, because you've got the minus 2x. So yeah, your directions will change. So again, start by moving your 3.
So you're going to change your symbol when you set it up with the or to begin with the -5. You're always going to change your symbol.
Yeah. Yeah. So you're basically changing both of these, right? You're making it less than equal to, and then you're putting a negative on the 5 to create your second side. Yeah, very good. All right, guys, so start by subtracting that 3. You will be left behind with minus 2x greater than equal to, what do I have on the right? 2 again, 5 minus 3 is 2. Now, we are dividing by a negative 2. So our inequality symbol has to change directions. Okay, we've got x on the left-hand side. What do we have on the right-hand side? Very nice. X is less than -1, so that would be less than. And it's less than equal to, so put a bracket. And it's less than equal to -1, right? Or, what do we get from the right-hand side?
I got +4.
Okay, so I've got 3 positive 4s. You're looking in the minority there, Levi. No, you do not. I have a suspicion you did something with your signs. You got a +1 as well? What are you guys doing? Stay away from Levi.
Yeah.
He's definitely the problem.
I'm just doing it myself.
That's what I did.
Okay.
I got that one right.
Oh, right there, -5 minus 3,
Oh, okay.
right? 2 negative numbers, what do you end up
Make a
doing?
positive.
So it was -5 minus -3 is.
No, it's just -5 minus 3. There's no negative.
When working through this, he's wondering why we flipped the sign at
The beginning, right
the
here?
beginning.
Okay, let's go back to that.
Because we didn't do it in 6.
Yeah. Did you do in 6?
6, yeah, we did.
But I told you to flip it and you.
Okay, you're probably not going to see that clearly, but right here, this was our original, and we did. Even in the 3 part, we did that also. The only difference was, are you using the word and, or you're using the word or?
Yeah, I just didn't flip it.
Okay, and you still got the right answer?
Yeah, if I did x less than 3/2 instead of x greater than 3/2.
Ah, okay, so you were in the other direction then.
Yeah.
Yeah, I've got to be very, very careful with that. Okay, last part, guys, divide by -2, which you have probably already done that. Nope. And x will be less than equal to negative or positive? Yeah, 2 negatives make a positive, so you have to end up x less than, and this is an or inequality, so less than equal to 4. Okay, so if we combine this together, okay, so I've got -1, I've got +4. Did I not change my direction? I didn't, did I? Because we divided by -2.
That doesn't seem right.
Yeah, that does not seem right at all. I'm blaming it on Levi. Okay, so we're going greater than. So opposite direction. Yeah, this is what I was hoping we would have. Okay, so we have on the left-hand part less than or equal to -1, which is going in this direction. And we've got x is greater than or equal to 4, which is going on this direction. Now remember, that's positive and that's negative. It's infinity. This is an or inequality. Go back and look at that table. If it's an or inequality, then this is what we have. You are looking at opposite directions, which means to combine them, we have to use these union symbol, right? Because there's no overlap between them. They're completely 2 separate sections, completely disconnected, if you will. So any idea on how we can write this in our interval notation?
Negative infinity,
Mm-hmm.
-1
Bracket.
and then you do the union symbol,
Right, the union symbol, good.
and then you would do bracket
Uh-huh.
4, and then positive infinity.
Very nice. Again, infinity does not take brackets, so always use parentheses. We've got brackets on both -1 and +4, so you will have brackets. And like I said, since these are 2 completely separate sections, we have to use the union symbol to say, okay, they are both part of the solution set. So that's what that union basically does for us. Very good. Okay, so again, less than equal to is either your three-part, or it's an and inequality.
Are we just better off doing it the other way?
You can, if that's easier to keep track of. So just remember, with the absolute value, if you see the less than, set it up as and. If it's absolute value with the greater than, set it up as or. Yeah. Okay. Okay, I need you to put your thinking caps on without cursing. And think about what's happening on A level. Because we have talked about this with equations. So if it helps, pretend it's an equal to sign instead of less than equal to or greater than equal to.
Absolute value starts out with 0, then it's already. Then it starts with a negative, it's a false.
Okay. So basically, your distance cannot be a negative number, right? And we talked about that. So in that sense, one of these has a solution and one of these does not. And obviously the idea is which is which. So number 8 is absolute value of 3x minus 7, and they're telling us the distance of this, whatever number will be, is greater than or equal to -5. Now, can we have a distance, a number, which would be greater than -5? Yes, because even if your distance was 0, it is still a number greater than -5, right? Even if it's 1, 2, 3, whatever. So this guy actually has a solution, and since all distances will be greater than -5, the solution for number 8, no, it's actually going to be all real numbers. So you can't actually solve this one. You cannot set it up as the two parts just because of that right-hand side having a -5. But we know all distance will be greater than -5. And that's why we can have all real numbers, because even if I used a distance of, trying to think, let's say if I plug in a number for x here as -100. So think about if my x is -100. -100 times 3? -300. And what is -300 minus 7? Yeah, you will just end up, actually, since it's -300 and then -7, it will become -307. Right? Because you end up adding two negatives. The idea is you will end up with -307 in here, but what does the absolute value do with that -307? Makes it positive. So we know +307 is still going to be greater than -5, and you can plug in any number for x, and you're always going to end up getting a positive answer.
So it's because the variable is first, or no? Like if it was 7 minus 3x?
It would still work.
Oh, it would?
Yeah, it would still work. So because you have greater than a negative number, you're always going to get a positive answer. This gives you all real numbers. So x can be anything. X can be any number from negative to positive infinity, and we're always going to have a solution. Now, let's think about this guy. And I'm going to use that 100 again for our x, and let's keep him positive 100. So if x is positive 100, I multiply that with 5, what do I get? 500. And what's 4 minus 500? Yeah, -496. Now, when you take, absolute value of -496, what do you get? Positive 496. Now, will positive 496 be less than -1? No, because positive numbers are always going to be greater than, right? So when you have a less than with a negative number, you have no solution. So this guy will be no solution. So both of these examples, the first thing we should notice is it's an absolute value inequality. The number on the right-hand side is a negative number. So I'm either going to have all real numbers, which is the first option, or I'm going to have no solution, which is my second one. It's going to be depending on the direction of the inequality, which gives you one or the other. So if it's greater than or greater than equal to all real numbers, if it's less than or less than equal to, no solution. It's an empty set. Okay? Okay, so just applications with inequalities. Here they're telling us Felix scored 52 points and 64 points on the first two exams in sociology. What should be his grade on the third test, so that if he took an average of all the 3 tests, he should have at least an average of 70 points. And they're saying all the tests are out of 100 points each. Okay, so he has 52 on the first one. What did you say after that? Okay. The second one, and we don't know what he has on the third one, right? Okay. Not quite an equal to.
70, you want the average?
Yeah, so how do you take the average? Very good. If you have 3 test scores and we don't know the third one, but we're calling it X, what's your calculation for doing an average?
You have both.
Okay, but they want us to the average for the 3 tests, right? So that means technically we are adding all 3 and divide by what? 300, yeah, because they're telling us each test is worth 100 points, right? Okay, 4 problems, I'm sorry. Okay, so they are telling us that Felix's average on those 3 scores should be at least 70. How are you going to set that part up?
Greater or equal to or greater than 70? X
Okay,
equal-
so-
X
Less
greater
than or
or
equal to 70.
Yeah,
Okay, so you're saying greater than, right?
or one of them.
Well, but that's the important part. Which one should it be?
All of
The one that's eating the 70.
At least 70, so it has to be greater.
No, it has to be greater than
Greater than
Other way,
The way?
other way. If you're saying the right word, you're making the wrong symbol. At least, right? Which means the minimum value has to be 70, but it can be more than 70, right? Which means more than 70, you're going to the right. So it's got to be the greater than equal to symbol.
So look like this.
If they said at most, then you would going the other direction, because then you're saying the maximum would be 70.
So like this.
Yeah, very good. Yeah. Okay, so what is it going to be? No, no.
We're doing just a check.
Okay, something's wrong in this inequality. What's wrong in this inequality? Yeah, because we're not getting the right answer. So what's the error in this? You actually had it before.
Listen.
No, that part is fine.
Oh, you put
Yeah, it shouldn't be 300.
3.
It should be 3. That's
I
what
knew
it.
it.
Since they are the equal weight, that's not going to give you the right answer. You're taking equal weights. You're just
They
dividing
don't have
it
300 tests.
by 3. Yeah, they have 3 tests. Okay, so that was the
Yeah,
error.
that's what.
You're like, whoa.
Yeah,
Something.
it's like, no, that's like 21,000. No, that's not an average. X is equal, well, greater than or equal to. Right? Yeah, because again, our idea is to get X by itself. If you want to add the 52 and 64 plus, you can do that first. If you want to start by dividing by 3, you can that first. Mm-hmm. Yeah, that would also work. Mm-hmm.
Wait,
Yeah.
so if it was equal, if the average was equal to 70,
Yes,
then it would be equal. I mean, the X would equal 94.
94, yeah.
But since it's greater than,
So since they are telling us that the average should be at least 70, which means your average could be more than 70,
Yeah, then it'll
which
be
means the higher you want that average to be, the higher your score on the third test has to be, basically. Okay, so yeah, you can see when we multiply 70 with the 3, you are still going to end up with that same value of 210, right? Okay, and then what was 52 plus 64? Yeah, 116. And all you have to do now is subtract that 116, and that will give us x is greater than or equal to 94. Now think about this. Felix scored 52 and 64, which are two numbers pretty close to each other, right, on those first two exams, but we are still hoping for an average, which would be basically a C average, right, at 70 as your average. So to be able to pull up that grade, because right now, if you just took that average between 52 and 64, what does that value come out to be? Which would be 116 divided by 2.
What?
If you just took the average of 52 and 64, what do you end up getting?
Yeah,
58, right? So you are talking about going from a 58% to a 70%, right? That's a 12-point jump. And to make that jump, you're pretty much looking at scoring 90, well, a mid 90 at least, to be able to jump to that 70%. And the reason why I use this example is, of course, we do the same thing. We're taking exams on all the chapters that we will be going over. So honestly, to be able to keep a C grade minimum, you have to at least score 60 to 70% on all your exams. If your score falls below 60%, it's going to take like that 90 something to bring us back up to even a passing grade. So, as you guys are going through your homework, practicing for your quiz, just kind of keep in mind, if you want to maintain that C average or B average, then your exam scores pretty much have to be in that same range. So for a C average, you got to have your exam score be in about 70%. If you want to do a B average, it's got to be average of 80%, that kind of average, so it will help you out. So on the third exam or third test, Felix has to score basically, yeah. Oh, it has to be, and I'm using the same language, at least 94. Okay, so what was our example here? Okay, this is talking in terms of pump certification. Okay, so they're saying if a gas pump is certified as being accurate, its relative error when it's dispensing 10 gallons of gas has to be less than 1%. So that means if it's showing you 10 gallons on the little meter when you're pumping gas, as long as it is only off at a less than 1% value, we can say that that pump is accurate. But let's say it's showing you 10 gallons, but it's pumping less than 10 gallons, basically like 9.5. Well, that's not good, right? You cannot be at that far away from your actual amount. So that's what we're kind of testing here to see what that range should be. So they're saying if X is the actual amount of gas that is being dispensed, then for what values of X will the pump be certified as being accurate? So again, we are talking in terms of relative error. They're telling us, and this is number 11. So if we are pumping 10 gallons of gas and X is going to be that value, which is the actual amount dispensed. So if X is, 9.99 gallons, or it is 10.010, something like that. Whatever is that actual amount that got dispensed, you're subtracting that from 10 to see how far away from 10 it was, right? And then with the calculation of relative error, you actually divide it again by that value of 10. Okay? But here's the thing, with relative error, we actually put that in absolute value. Because we want to know, is it pumping less than 10 gallons or is it pumping more than 10 gallons? So we don't know on what side of 10 gallons it's going to fall. And then in this case, they are telling us your relative error has to be less than 1%, right? So obviously that means less than. What is 1% as a decimal? Very nice. So the actual amount is X. We know we're looking at this in terms of 10 gallons of gas being pumped, so we're subtracting it by 10. And with relative error, you actually divide by that same value of 10. Put the numerator X minus 10 in absolute value, and then they're telling us you have to use the less than symbol, right? Because they're saying it's less than 1%. Percents, again, guys, by default, we always convert percents to decimals, so don't leave that as 1. Make sure you write that as 0.01. Okay, now to get our X by itself, what's the first thing we should do here? Yeah, get rid of that denominator. Multiply both sides of your inequality by 10. We're left behind with absolute value of X minus 10 less than equal to, yeah, 0.1. Set this part up, and we've looked at a couple examples with this now. Yeah, so how would we break this guy down? Absolute value of X minus 10 less than equal to
You could do,
0.1.
you could do both, right? Like,
Since it's less than,
Mm-hmm.
it's gonna be a or.
No.
oh, I'm sorry.
It's an and. So either a three-part, well, that's a three-part, either a three-part or set it up as an and inequality.
But we can do
Levi,
this.
you and I are talking after class today, buddy.
I was looking at that equivalent statement, sorry, no, absolute value.
So what do we want to do, three-part or and? Okay, thank you. I was hoping somebody would say that. X minus 10 goes in the middle, right? Less than equal to 0.1. So this is basically where you set it up the same as the inequality without the absolute value. Now for the other side, since we're doing this as a three-part, you're actually going to keep your direction the same for the inequality. The only exception is obviously make this guy into a negative number. Okay. Okay, to get X by itself, yep, very nice. Add 10 on all three sides. This guy's pretty simple. You got X by itself sandwiched between, what would those two numbers be? 9.9, yeah. 1.1, right? So that's your 1% error. So as long as, the gas pump, how do I want to say this? The gas pump dispenses, I guess, between 9.9 gallons and 10.1 gallons, it is accurate. If it's dispensing anything outside of this range, so less than 9.9 or more than 10.1, then obviously it needs to be recalibrated. Basically, it's not doing what it's supposed to do, because, you know, obviously you don't want to pay for 10 gallons of gas, but you're only getting like 9 something, right? Not even close to 9.9. Now, if you're getting probably 10.5 gallons, you're like, hey, it's okay, right? Half a gallon extra, I'm cool. But if you were on the lower end, you'd be like, okay, no, give me my money back or something.
I'm sure the gas companies would be pretty pissed if it was.
Well, yeah, I mean, it's a huge loss, right? And gas is such a prized commodity, especially right now, since China is not buying as much gas, because obviously we're all like, ooh, coronavirus, so nobody go to China, don't even think about China, stay away from China. You know, there's all these rumors going about, like if you're getting those, you know, air-filled bags that they use for packaging now, bubble wrap, don't pop it because the air is from China. And I'm like, really, people? So, you know, the gas prices have plummeted because China is not buying as much right now. And so they are trying to hike up the prices here because they don't want to give gas away for cheaper than what they're already charging us right now. So, this is all a big economic, how can we make more profit? We don't want to lose our money kind of situation. So obviously the gas company is not going to want us to give more. And obviously as consumers, we at least want to get what we're paying for. So you will notice on gas pumps, they put those little stickers and they'll have punch holes for when that pump was basically checked, when they came and did their inspection. So they'll have the month and the year punch, so you'll know how recent that inspection was, and okay, everything's fine. It is dispensing as much as it should. So this is kind of the setup that we would do for an example like this. Okay. Question?
Oh, no, just right.
Okay. Anybody have questions on any of these examples? Okay.
Since this is when we write it in the graphing solution, where you putting a bracket, this setup.
Are you talking about 11? Let me go back. So, hold on a second. I don't know why I made it equal to. That was just a less than. Can't believe I did that.
How would you write that? Like, would you still do the U?
So this one wouldn't be a U because we're saying as long as you are between 9.9 and 10.1. So you would just write it as with parentheses between 9.9 and 10.1. I honestly don't remember what my MATLAB does. Do any of you, has anybody gotten to this problem yet? Well, obviously half of you can't even get into your homework. I am not sure, Iram, what my MATLAB asks you to do about this. We can kind of take a